Hey folks, welcome back to our course in trigonometry. Dr. Tom McNamara here. In this video we're going to introduce something called a reference angle. And I figured I would show you an example, something like we've already seen actually. If you go back to some of the chapter 1 videos when we were talking about angles in standard position, we actually brought this idea of a reference angle up without explicitly calling it a reference angle. But let's say I wanted to do this, find the exact value of sine 210. Okay, now when we're talking about exact value, this thing goes out the window. Okay, we're not allowed to put decimals, nothing like that. Okay, so, and remember, the only time I would ask you for the exact value of a trig function is if it's a special angle. And what do I mean by special angle? Well, I mean you can work in a special triangle. So let's think about the angle 210 in standard position. Okay, it would take us to somewhere about there. Remember, standard position, we're talking about starting at the positive x-axis and we are rotating in the counterclockwise direction. So we're here, that's 90, that's 180, we would go a little bit farther, and now we're at 210. Well, how much farther? 30 degrees farther. Okay, so 30 degrees, you'll remember, is part of a 30, 60, 90 triangle. So we're going to bring in a supplementary triangle here to help us. Because remember, if I'm talking about finding the values of the trig functions, and I'm talking about this angle in standard position definition, if I'm talking about finding the values of some trig functions, I need a point on the terminal side of my angle. I need coordinates right there. And I need to know what this is. I need to know R. Now, if I am bringing in this little supplemental 30, 60, 90 triangle, I'm going to have this picture kind of in my head. I'm thinking about this. Okay, so the short side has length 1, the hypotenuse has length 2. The side adjacent to the 30-degree angle has length radical 3. Okay, so that means this length right here is the radical 3. This is a 1. Now we've gone radical 3 units left from the origin, so my x-coordinate, negative root 3. I've gone 1 unit down, y-coordinate, negative 1. My hypotenuse is 2. Okay. So, exact value of sine 210. Well, the sine, got to think back now to that stuff in the first chapter, the first definition that we encountered for the 6 trig functions. Sine is y over r. So, negative 1 over 2. All right, so 30 degrees is the reference angle. Okay, 30 degrees is the so-called reference angle. Very helpful tool for working with trig functions. Okay, the reference angle. Now, to make the reference angle, you always go to the x-axis. Always go to the x-axis when you're looking for your reference angle. Let's look at a couple of examples of finding reference angles. Now, we're not looking for values of trig functions for these problems. We're just going to get practice finding reference angles. Find the reference angle for each. Okay, so this first one is is going to be so easy some people might get tripped up on it. 40 degrees. We imagine 40 degrees in standard position, it takes us right there. So the reference angle is 40 degrees. Okay, that's the reference angle. Let's look at 160. Okay, now 160, that would put us in the second quadrant. Okay, so we're going over here. Right, that's 90, so I've gone 70 degrees past 90. Now down here, this is 180. And remember, for my reference angle, I'm always going to the x-axis. Go to the closest part of the x-axis from your terminal side. So if I go 160 degrees, I'd have 20 degrees more to go to get down here. There's my reference angle. The reference angle is 20 degrees. Okay, so your reference angle is always going to be an acute angle, okay, something between 0 and 90. That's going to help us combine the two definitions of trig functions that we have. Remember, in the first chapter we talked about angles in standard position. In the last chapter we talked about right triangle trig. We'll be able to mold the two together here. Okay, let's do this one. Let's go 325 degrees. Okay, so I'm right here, starting out, rotating in the counterclockwise direction. I'm at 90, I'm at 180, I'm at 270. Okay, 325 is going to take me over here into the fourth quadrant. Okay, the closest part of the x-axis is back up here. So here's my reference angle. Okay, so this is a 325 degree rotation in the counterclockwise direction to get us that angle in standard position. Our reference angle is what's left. Now, going all the way around, that's what would happen if I went to there, right? I would have gone a full revolution. That's, of course, 360. So this is 35 degrees. Okay, your reference angle for 325 is 35 degrees. Okay, just one more. I want to do a negative one. Let's do negative 250 degrees. Okay, so we're going to imagine this situation here. Actually, it's not where I need my space. Negative 250 degrees. Okay, now of course, if we're dealing with a positive angle, that means we go in the counterclockwise direction. If we're dealing with a negative angle, we rotate the other way. Okay, so we're starting here. We're rotating through an angle of 250 degrees, which would take us up here somewhere. Okay. So that's 0, negative 90, negative 180. This would be negative 270, so that's too far. So we stop right about there, negative 250. Remember, we're always going to the closest part of the x-axis. Okay, the closest part of the x-axis. This is negative 180, so that is an angle of 70 degrees. So you're dealing with an angle of negative 250, your reference angle is 70 degrees. So remember, reference angle is always an acute angle, and you find it by going to the closest part of the x-axis from your terminal side. Now, your textbook actually gives us like a little, it's like a scheme to do things, a bunch of if-then statements. To be honest, I don't remember those. I draw my angle in standard position. I think, what do I have to do to get back to the x-axis? What's the angle that makes me get to the closest part of the x-axis? And that's how I get my reference angle. So it's going to be a very useful tool as we move forward. We just saw an example at the top of me using a reference angle to get the exact value of some trig functions. We had sine 210. We wanted to find the exact value. We used the reference angle of 30 degrees because we brought in that 30, 60, 90 triangle. Okay, so this is going to be extremely useful as we move forward in the course.